you watched an introduction into what is called Boyles Law, and they just showed you the formula P1V1 equals P2V2. Now you'll want to make sure that you follow along as I go through how to use this law and how to calculate with this law. This is what this particular video is going to be about. So let's use an example. A gas is held at 1.2 atmospheres and 5 liters. If its pressure changes to 2.4 atmospheres, what is volume 2? Now, what I'm going to do is, if you will pause the video, give everybody a chance to write this down, then we're going to work this problem. I'll come back in just a second. All right, now that you have this question, let's see if we can work it out. A gas is held at a pressure of so many atmospheres and liters. Now, remember, there are some things that you have to know. We've already talked about units of pressure, so you should know by looking at atmospheres that that's pressure, and liters is going to be volume. The very first thing you want to do is start by writing the formula P1V1 equals P2V2. Students, listen to this very carefully. You're going to need to write the formula and plug the numbers where they go. Over the next couple of days, you're going to have multiple formulas. And so you have to know which formula you're going to use and plug the numbers in order to get the answer correct. A gas is held at 1.2 atmospheres. And I just put it right where it goes, and 5 liters. If its pressure changes to 2.4 atmospheres, what is volume 2? Now I'm going to use an X like you do in your algebra class, solving for volume 2. Now the most important thing to know about working these problems is that units have to match. Pressure 1 and pressure 2 have to be in the same units in order to calculate. In this case, I have atmospheres here, atmospheres here, so I can work the problem. That means when I work the problem, it's automatically, since these have to match, it's automatically going to come out in liters. I already know that. And here's why algebraically. I'm going to take and show you what mathematically is really happening. Let's just pretend this is an algebra problem. They're side by side, so you're going to multiply. So to solve for x, you divide by 2.4 atmospheres. You'll notice the word atmospheres disappear. Liters is the only thing left. That's how I know it's in liters. It's simple mathematics. I grab my handy dandy calculator. 1.2 times 5 on the top divided by 2.4. The answer is 2.5 liters. And that's my answer. Very simplistic, not very difficult. The gas laws are not going to be very difficult for you. It's simple algebra. The biggest part is putting the numbers where they go. Let's try another one real quick. This time I'm going to change the units up a little bit. Instead of writing the whole problem out, I'm just going to give you the information. A gas has a pressure of 120 kilopascals, and the pressure is going to change to 185 kilopascals. If the volume was 427 milliliters, what is volume 2? Again, I'm going to start with the formula and plug the numbers in. P1V1 equals P2V2. Start with the formula, plug the numbers in. I've got 120 kPa, and it's going to go to 185 kPa. Notice they are matching units, so I'm going to be able to work this problem. I have a volume of 427 milliliters, and there's my X. There's my equal sign. Now, next thing to notice, they don't always have to be one unit, as long as they match kPa and kPa. So my unit's going to come out in milliliters. It's simple calculator work, so I'm going to take my calculator again. I multiply on the left. I'm going to divide by who's with the X because it's going to have to be divided. So it is 120 times 427 equals, on the top, divided by 185, and I get an answer of 276.97. 276.97 milliliters. Now, a couple things I need to tell you real quick. That's the right answer. And you remember when we always come down to, notice the answer on my calculator, multiple decimals. That's not really a problem until we use the computers. And in a couple of days, or maybe a little bit later today, you're going to work on the computers. It always checks for sig figs when you're on the computer to get it right. So let's just make sure we know how to do that. Remember, sig figs, when you're multiplying and dividing, it's always the least sig figs. This number has 3 sig figs. This number has 3 sig figs. This one has 2. Remember, the 0 is a placeholder. So my answer is going to be 2 sig figs. So I go 1, 2, stop. So my answer is 280 milliliters. Now, if you were doing it for me on a calculator, 1 decimal place is great. Or if you're doing it for me on a worksheet, we'll just go 1 decimal place with all of our answers. But if you're on the computer to get the grade and get it correct, full credit, you have to go sig figs. Not hard. We already know how to do that. Let's try one more. Notice that in this problem, I used kilopascals. In the first problem, I used atmospheres. Let's try a problem that uses torr. You have a gas that has a pressure of 780 millimeters mercury. Remember from a couple of days ago, that's the same thing as torr. They can use that word or that word, doesn't matter. They want to know what is volume 1 when the pressure changes to 815 torr and volume 2 is equal to 1.67 liters. All right, remember, start with your formula. P1 V1 equals P2 V2, and you should be copying all of these problems with me to make sure you've got it. A gas has a pressure of 780 torr. I can write torr, it's the same thing as millimeters of mercury. Notice they match. So this is going to be 815 torr. Fix that real quick. 815 torr. What is volume 1? When the other volume is 1.67 liters. Now notice this time the X is not on the right hand side. It doesn't matter. Read the questions carefully. They will tell you which thing you don't know. In this case, your unknown value happens to be on the left hand side. So you're going to end up dividing by 780 to move to the other side, and you can get the answer pretty easily. So you're going to end up dividing by 780. So I grab my handy dandy calculator. 815 times 1.67 equals, divided by 780 is 1.74. 1.74. Matter of fact, my calculator says 1.7449. What units? Well, a torr cancels torr. This answer is going to be in liters. Now, we said a while ago, we'll do, if you're doing on paperwork, we'd go 1 decimal place, so 1.7 would be the answer on paper. But if you're doing it on the computer, check sig figs. 3 sig figs, 3 sig figs, 2 sig figs. So you'd have to go to 2, so it'd be 1, 2. The 4 doesn't make it round, so either way, 1.7 liters is the answer. What you're doing for Boyles Law is you're literally taking the numbers, plugging them into the formula, and solving for the values that you should be getting. In the next video, you're going to practice a few on the screen. Make sure you do all the calculations so that you know exactly what you're doing, and then you're going to have some to try on your own. Good luck!